In this lecture, we're going to extend some of the ideas we introduced in the previous video to the study of business analytics. And by definition, business analytics refers to the application of processes and techniques that takes raw data and transforms and analyzes that data into something meaningful that can be used by business and management to enhance decision making. Very often these data, or the capturing of these data, is referred to as business intelligence or intel. And whenever you hear the word intel within the context of analysis, it's a simple reference to the process of gathering information under data science, as a branch of data science. And so what is the whole point of intel? The whole point of intel is to gather information in the form of data, in the form of numerical values, in order to identify patterns. And once those patterns have been identified, it enhances the understanding of a particular situation that might be important to a business or to any organization that can be used and applied with some inherent value. And in this lecture, we'll talk a little bit about big data. And big data, just for now, is a simple reference to an enormous amount of information that at first glance is very difficult to analyze. But it refers to an enormous amount of information that is captured under the intel aspect of business analytics. So the gathering of intel is all about determining in the first stage of whether it's useful. But once that intel is gathered, it has to be analyzed. And once it's analyzed, part of the data may or may not be useful. Perhaps none of the data may be useful, but that decision can't be arrived at without some systematic way of analyzing the data. And then once the analytics have been completed, then better decision making can be made once the individuals can decide what to do with the analysis. And this decision will take the analysis and put it into context with what is important to the organization or to that business. Now, when we talk about big data is a simple catch-all term that refers to the collection of a very large amount and very complex data sets from different sources. And often these big data presents a significant challenge to try to identify patterns in those data, and oftentimes the use of artificial intelligence can be used to examine some of those patterns. However, the techniques of standard statistical procedures can be very useful to analyzing big data as well. So where do we get big data from? Well, when we talk about consumer information, we're looking at very large amounts of data that are collected on a daily basis. Labor statistics, financial data, human resource data oftentimes presents very large data sets, very large spreadsheets that at first glance can be very challenging on knowing where to start. There are 5 key characteristics of big data that we'll cover in this unit. That includes variety, velocity, veracity, volume, and finally value. The first factor here of variety is to understand and be prepared that data comes in many different forms, and it's based upon the actual data source. And these sources of data can come from government databases, mobile phones, or scanners. What I have here on the slide is a poster for a movie titled Vice. That's a biopic of one of the vice presidents of the United States in the early part of the 21st century. And it's an interesting movie because a major component of the movie deals with the government of the United States gathering big data illegally from citizens in a wide-ranging surveillance program. So it's an interesting movie, humorous movie of real-life events that that covers the government's use of big data. Now, with respect to the variety, there are two general types of big data variety. The first is structured, and so some government organizations or departments do provide downloadable spreadsheets, particularly if we're looking at publicly available information. And that certainly helps when we want to collect information on the population or data as it relates to financials or consumer data. This information is much easier, once again, if it's made publicly. And so the government can provide this information directly from websites or upon request, or from different popular media sources as well. The other type of variety of data are unstructured. And so this type of data here presents the researcher much more of a challenge in gathering and organizing. And so if information is gathered from photos or text, that often needs transcribing. The second key characteristic of big data is velocity, and as the term suggests, it refers to how fast the data can be obtained and or processed. And this is typically important in those areas where data needs to be updated in real time. And what we see here is a screenshot capture of the market value of the Toronto Stock Exchange of August 30th, 2024 at market closing. And so throughout the day, this graph is updated on a minute-by-minute level for traders to do their work. This index needs to be updated in real time, and so in order to do that, lots of pieces of information have to be funneled in and calculated to work up the value of in this case, the TSX composite index. The third type, or the third characteristic, is veracity. And when we think about veracity, one term that usually comes to mind is truthfulness to the data. Is the data valid that we're getting? You can get lots of data, but this goes back to an early video where we talk about garbage in, garbage out. So the data must be of good quality, accurately and correctly represents the variable for which those numbers are representative of. So once again here, if your data lacks quality, makes inaccurate representations, or is just simply not correct, there is no statistical procedure that can clean that up per se. So the adage that garbage in, garbage out is particularly applicable here when we talk about big data. And so the problem we have with big data is that researchers can be so overwhelmed by the sheer volume, is that there may be a lack of accuracy, precision, reliability, and trustworthiness of the numbers that the researcher has obtained. And if that's the case, it can lead to anywhere from poor decision making to catastrophic decision making. And so catastrophically, that could point to to an existential crisis of a business, where a business may actually cease to operate if the data that is being used to make decisions lacks accuracy, precision, reliability, and trustworthiness. So all in all, when we think about obtaining data, particularly big data, the data must be legitimate. The fourth characteristic here is volume, and that refers to the size of the database, and this certainly depends upon the field of study. For example, when we talk about consumer data, people make purchases every day, so there's always a continual growth of that database. And a researcher that is interested in tracking consumer data must establish very clearly defined variables in order to arrive at reasonable conclusions. And the fifth characteristic of value is that we ask the question, is the data meaningful? We can have our hands on a tremendous volume of consumer data, for example, and the consumer data may show a particular pattern, but is it meaningful to a particular company? And that's where context is very important. And so does that data, does that analysis answer a question that's actually important? What defines importance? It really depends. It depends on the researcher, it depends upon the unit in the organization, and it depends upon the overall operations of the organization as well. In terms of business analytics categories, there are three progressive categories here that are important, and this was touched on a little bit earlier in another video. And the first step here is a descriptive analysis. So if an organization or a researcher gathers up information, gathers up numbers, the simplest first step that always needs to be carried out is the descriptive analysis. And the descriptive analysis will potentially reveal a pattern in the numbers if a pattern actually exists. And so this step will take raw data obtained from a number of different cases, and combine it and condense it into something that's understandable. Understandable to the analyst and understandable to the consumer. And that's where graphs, charts, two very effective ways to convey descriptive data. Summary statistics, a list of summary statistics that are generated from the raw data will reveal patterns that will not be apparent when just examining a spreadsheet of numbers. So following the first step of descriptive analysis, we then move on to the next step of predictive analysis. Can the data that has been summarized in step one be used to predict a future event? And that's what we're doing with predictive analysis. It examines relationships first inside the data set that a simple descriptive statistical approach by itself alone cannot reveal. And so this represents a different set of statistical procedures, equations, and formulas that we wouldn't apply in step one that would help to reveal those particular patterns. And if a pattern has been identified, can those data be extrapolated? In other words, can the data predict events outside of the conditions from which those data were obtained? One application is forecasting. Can a business forecast potential earnings in the next 6 months when those 6 months haven't yet happened? Weather predictions is a type of forecasting. And so what the second step of business analytics attempts to do is to apply what are called models, or predictive models, which are mathematical expressions that attempt to predict a future event from information gathered in the past or gathered in the present. The third step here is prescriptive analysis. So after data have been described, after predictive relationships have been identified, if those exist, what are we going to do about it? And that's the prescription, or the prescriptive analysis. That's considered to be the final phase. And so in this phase, we're using descriptive and predictive analyses to determine the best choice solution. Now, this is not just simply doing what the numbers tell us to. It has to be interpreted by the researchers and by the analysts. And it depends upon the situation, and it depends upon the question. And so this step will take current data that is summarized descriptively to forecast situations, to predict those situations, and then advise for a prescription. And one can imagine a medical scenario that if a patient comes in to visit a healthcare professional, the healthcare professional will start to gather information to describe their various characteristics. Based upon that analysis, they might be able to forecast a prognosis in the future, and once having that set up, the healthcare professional will be able to apply a particular prescription as some sort of medicinal intervention or some other therapeutic intervention. Now, the prescriptive approach is certainly not perfect. Even with the best quality data that is gathered, there's always a degree of uncertainty, and that uncertainty can be quantifiable. And by understanding uncertainty, decision makers will be in a better position to understand the degree of risk of the decisions that they make, and it provides an opportunity to put and to incorporate measures that would mitigate any risks of their decisions. And so this provides the decision makers of a business, as an example, to deal with potential losses in making a risk versus reward decision on how to move forward in a particular situation, in a unit, or with the organization as a whole. So this ends our final video of our introduction to statistics.